Hi, this is Alex from devstories.eu. Pillow, the imaging library, episode 5 of 5. You import a massive computer vision framework, pulling in gigabytes of dependencies just to flip a few training images. You do not always need a heavy, specialized library to build a robust augmentation pipeline. Sometimes all you need is lightweight augmentation, the ImageOps module. Before looking at the functions, we need to separate ImageOps from the image filter module. Listeners occasionally confuse the two. Image filter applies convolution kernels to an image, calculating new pixel values based on their neighbors to create blurs or find edges. ImageOps is entirely different. It provides ready-made pixel mapping operations. These are direct, fast transformations that manipulate the color or position of individual pixels without relying on complex neighbor math. If you are preparing a dataset for machine learning, ImageOps gives you instant tools to multiply your data. You have deterministic spatial augmentations. The mirror function flips your image horizontally, swapping the left and right sides. The flip function flips it vertically, swapping the top and bottom. Both operations preserve the exact dimensions of your original data, just reoriented. You also have immediate access to color and contrast adjustments. The grayscale function converts your image to an 8-bit black and white format. This is commonly used to reduce the dimensionality of your input data when color is not relevant to the classification task. The invert function reverses all color channels. An 8-bit pixel with a value of 0 becomes 255, turning a white background black and red pixels cyan. This is highly effective when generating negative masks for segmentation tasks. Here is the key insight. The auto-contrast function is particularly useful for standardizing raw datasets with inconsistent lighting. It calculates a histogram of the image, finds the darkest and lightest pixels, and stretches the color range so the darkest pixel becomes pure black and the lightest becomes pure white. You can pass a cutoff percentage to the auto-contrast function. This tells Pillow to ignore extreme outlier pixels, like a single bright sun glare, when calculating the new contrast curve. Consider building a simple data generator for satellite imagery. Satellite photos look valid from any orientation, so you can safely double your training set with spatial shifts. You write a function that takes a directory of images. For each file, you load the image. You generate a random integer. If the integer is even, you pass the image to the mirror function. If the integer is odd, you pass it to the flip function. You then save the resulting image under a new file name appended with the transformation type. You just multiplied your dataset using a standard library, keeping your deployment environment exceptionally light. Instead of reaching for heavy machine learning packages for basic data preparation, checking the official documentation for native solutions prevents dependency bloat. Hands-on experimentation with these built-in tools will drastically simplify your pre-processing scripts. If you want to suggest topics for a new series, visit devstories.eu. That's all for this one. Thanks for listening and keep building.